Hello, everyone. Welcome to the September 21st, 2021 Open Planetary Lunch Talk. I'm Chase. Our speaker today is Zac Trolley from the Lunar Water Supply Company. We'll be talking about accelerating planetary science with EnkiGIS. Thank you for being here, Zac.
It is my absolute pleasure.
And when you are ready, just go ahead and start talking.
Awesome. So my name is Zac Trolley, and here to talk about EnkiGIS. It's our software we're trying to develop to accelerate planetary science, but also enable resource prospecting. When we started Lunar Water, we come from a resource background, and we went looking at the data types and data tools and everything available, and nothing was there to start working immediately. So we figured, well, we need to start working on that. So real quick outline to do an introduction, kind of go over the problem we're trying to solve, how we're doing it, our roadmap, and obviously some Q&A. And nothing is set in stone. This is our ideas. We could be very, very wrong in our assumptions. So honest feedback is greatly appreciated from what we're going after. So first of all, my name, Zac Trolley. I'm an electrical engineer, and most of my experience has been as a project manager in the oil and gas industry. I'm an International Space University alumni and was also on the NBRS 188 crew. Canadian, Lunar Water Supply is a Canadian company. And we're a resource company first. So we're looking to integrate tech, not develop tech. So we're not going to be building rovers. We're not going to be, building drills. Just like a resource company doesn't build their own trucks, their own buildings. They partner and they get contractors with that. And we're following a prospect construction operation roadmap, and that's currently where we're at. We are a startup on sweat equity, trying to build a business case within Canada for space resources, and that's where we're sitting today. I'm sure everybody here knows this. We are focusing on water because it is the enabler of everything else in ISRU. We could be going after platinum, concrete with regolith, but you need water for everything. So that's where we're focusing on that. We're hoping to become a utility on the moon, providing water to everything in cislunar space. So that's our goal. That's our mindset for long-term stability in space exploration. And we're following I don't know how familiar you are with typical resource projects, but this is the kind of the roadmap. So we started in prospecting. What is there? We do exploration. Kind of what the Viper mission is doing, that's more the exploration. Then we get into the engineering when we know exactly what our resource is and what's it about, construction and operation. So we are at the very beginning of this exercise, looking prospecting for those resources, trying to find water and try to understand everything about that water. And of course, what we need, we're in exploration results, we being, the world. And what we need to get in a resource world, in funding resource project, is to prove resource. And I mean, I can't remember what report this is taken from, but it pops up all over the place. And this is the roadmap we're trying to follow with EnkiGIS to enable this roadmap to happen, so that we remove all the unknowns, can bring in the large amount of investment we obviously need for resources, and get ourselves down to the bottom right quadrant. So the problem is, of course, we know there's water in the moon, but there's very low confidence about the reserves of water. So it's an important distinction of language. So a resource, we know there's different things, different compositions at a planetary scale, but a reserve is within these 4 square kilometers, let's say. Where is the water? What is the shape of the deposit? What is the percent quantity in that shape, whether it be in the PSR on the surface subsurface ice, and then how much of that can we be recovered using this tech. So it's basically this 5 square kilometers, we can actually extract this amount of water, right? It's never 100%. So that's what that reserve means. And there's a lot of questions we need to answer, obviously, from that, contaminants, inputs to the extraction process, all the way to like the terrain ability to hold heavy machinery. If we can't land the equipment needed to extract that resource, that reserve isn't viable. And that's the level of information we need to get to. And we're hoping that EnkiGIS is able to get us there. So we are working in this intersection between the resource industry and planetary science, where we aren't necessarily looking at the natural processes, right? We're not trying to find out how the moon formed and things like that. But the history and origin of the resource is important to identify the location and attributes. The same kind of thing, right now we're not focusing on the mining hardware. We're figuring out how to detect these resources, identify locations, and then look for those potential reserve locations. And again, this is a widely known gap in this information that we're trying to bridge. And of course, I think everyone's obviously familiar with GIS here, but EnkiGIS will house GIS products from sensor data. So we are not trying to build a new QGIS or full tools. What we're looking to do is make data from PDS, from other archives, from private ventures eventually available as GIS layers that people can get to work quickly. So you don't have to spend as much time analyzing data and working data and manipulating it to actually get a layer, but the layers are all there. And in the resource world, this is pretty much done for you. If I'm in Canada and I want to download layers of where resources are, rivers are, that's all available. Kind of same thing with the USGS. All this data is available. It's not really that easy to find for the moon right now, or any celestial body outside of Earth. So that's what, in a nutshell, that's what EnkiGIS is planning to be, as well as house higher order products. So you can download, white papers that have ice favorability indexes, but getting that as a layer, on a GIS map that you want to manipulate and add to can be difficult. So we want to, have that data available for people to access as well. So we want GIS to contain all relevant raster and point data sets. So that's going to include, mineral samples, coring samples, as well in the same database. So it's very familiar as an oil and gas database, where you'll have all your GIS layers, but you also have point data where well logs are, where weather information is, and all that kind of stuff. Obviously, no weather on the moon, but the same, let's say, database formats persist through that. We want to be able to ingest new data sets as they're created. So the pace of missions is going to rapidly increase. The past 20 years are going to look vastly different than the next 20 years. So we want to build a pipeline that can ingest that data quickly and get people working on that. Like I said, higher order data sets from studies and white papers available for manipulation and downloading. A drag and drop mapping pipeline, similar to like a shader style, where you can just easily take two maps, add them together, subtract things together to create higher order maps somewhat in real time. Basically a sandbox feature, right? To answer what if questions. What if we were to multiply these two things together? What happens? And provide that quick analysis and support data fusion between different data sets. So you can have neutron spectroscopy along with topography and other data sets, and have them in the same place. You don't have to switch back and forth, and then export to standard formats for further analysis. So EnkiGIS will house all these data sets if you want to get really deep in the analysis. we're not going to be building, those tool sets that already exist in other tool sets. And the big thing that we want to get to, this is a slide from the Lunar Ore Reserve standard, which is floating in a quasi state at the moment. But we want to base, this as a prospecting tool and have these things built in. So if I say, let's say, for example, I have an inferred resource, and inside the layer, it says, here's an inferred resource map. It will have all the, the metadata attached to it, how it got there, why people know that. And that inferred resource is a known terminology that fits with everything else. So that it's easy to, communicate with each other about what we mean by which words and set it to verifiable standards. And this is the only way from a resource lens that we can move forward. Because if I say, let's say again, inferred resources, I need to know that my engineering team understands what that means. My financial team understands what that means. My investors understand what that means. So it's really creating this space where all the data sets are set to the same standards so that we know what we're talking about and what level of confidence we have about these resources. So right now we're working on our MVP, and we're hopefully get that out really soon here in the fall, and work through the year on that MVP to begin building the feature sets that's enough to commercialize, that someone's going to be willing to pay a monthly fee to access these tool sets. Could happen next year, could happen, who knows. Then we want to also start including other features like private data sets. So there are many mission architectures that will recoup their costs by selling their data. And it's either you sell the whole lump for $50 million or you sell, by the square kilometer, right? We want to enable that by the square kilometer marketplace for this data so that people can access this data without having, access to huge company archives. And then moving to cloud analysis to be able to create layers based on machine learning and other things like that to become the source of truth for these data sets. So I'll use altimetry for an example. Taking all the data on topography and altimetry and blending them together so that we have a map that we're pretty at 95% confidence this is the current terrain height of the moon, rather than having to go to the raw data every time and start from scratch. That we will have GIS products ready to go at certain confidence intervals to say, hey, if this is all you need, this is good enough. You can start working from it right away. In our MVP, our first goal is basically to do a lat-long data set lookup. So you put in a location and a radius, and it will return to you the data sets and the locations where they sit in PDS. So basically, click and go rather than hunting yourself. Moving towards a complete data, making sure we have all the data sets that people most frequently use. And then going to a UI interface and then developing those tool sets people need to get their work done. And ideally helping people publish papers faster and do their research papers faster. Once we're figured that out, it's replications. Can we go through the top 20 cited papers and replicate, how they did their analysis in EnkiGIS? Can we get those high-level products in EnkiGIS, start moving, and then move into commercialization once it's up and running? This is, of course, is very, very aggressive. Will probably slip, but that is our current roadmap goal. So pretty short description here. So in summary, EnkiGIS is a tool to accelerate planetary science and enable prospecting. By putting all the data in one spot, easy to access, easy to get to. With the metadata records, if you want to dive deeper, you can dive deeper, but we're starting at a higher order level, and that's where we're going through. So we're not carrying any calibrations, we're not carrying any of that information. It's right to the GIS layers. Accessibility and usability is our primary focus, making sure that this data is easy to get to and fast to get to. And we want to be information hub for the space resources industry that, you know, hey, I need this map. We're going to go to EnkiGIS to get that map. And for discussion, I mean, the basic, I want to hear from you guys. Is this a tool that you would use? And if so, what kind of features would you like to see? You can send me an email, or I'm on the Planetary Slack. You can send me a DM and I'd be happy to chat and hear your thoughts. And that's the pitch in short.